Hi everyone, this is Santosh Kumar. Welcome to NX training. In today's video, we are going to continue with the modeling workbench. So today we are going to look about the datums. So here the datum planes is actually used to create the plane references. By default, it will be inferred. Under datum plane, we'll see what are all the options available. If you see inferred, at distance, at an angle, bisector, curves and points, two lines, tangents, through objects, points and directions, on curve, then view plane. We'll look one by one what exactly these planes are capable of doing. Inferred plane means it will automatically select a plane for you, and you click that particular plane, you will get a plane at a distance. You can specify the distance value. So say for example I specify it as 10 mm, or you can select this vector and pull it forward and backward, and you can adjust the value of the distance. This way you can create, but you particularly need a type of planes that you want to create, then you can go with the variants. I will go one by one. At distance is used to create a plane at a distance. You select any plane, you can create a plane at a distance. You can offset that plane to a certain distance. That's the use of at distance. At an angle, plane reference, and a through axis. You can select a plane reference. I'll select the XY plane as the plane reference, and I'll select the axis, that is the Y axis. So I can rotate that plane about the Y axis. Next we have bisector. Bisector needs two planes. So I will just create a plane for now. Now I have the XY plane over here and another plane which I have created here, and I want to create a plane between these two. Then I will go to bisector planes. I select this plane and this plane. I'll be getting another third plane between these two planes. That's the use of bisector. Uh, Next, curve and points. Yeah. Now if you see here, I have created some a line as well as point in a different plane, and another curve in a different plane, that is XY plane. Now let's see how exactly the point and curve plane works. So now we'll select the curve and points, and we'll select the point first, and then I select this plane. As you can see, it is creating a plane with respect to the point as well as this line. So this is how it creates a plane. Now instead of selecting this line, I select the other line, and it creates a plane in that with respect to that point on a curve. That is the use of this curve and points. Next, by two lines. So I have created another line. Now we select this particular plane, datum planes, and by two lines. I first select this line, and then the second line I would select this line. It would create a plane which is parallel to these two lines. So as you can see here, the plane created is parallel to the first as well as the second line. That's the use of by two lines. Next, tangent. If the tangent, now I select the surface of the cylinder, it will automatically create a plane which is tangent to this particular surface. So that's the use of this tangent. So under this you have much more variants, that is tangent, one face, through point, through lines, and two face, angle to a plane. So all these things will be tangent to the subtype parts that you have created. Drop down, so you will get the at that particular point you can change the orientation of that plane. So that's the use of this point and direction. Next you have on curve. So anywhere on this curve you can select, and then you can adjust that points, the plane length with the help of this arc length. So either you can give it by percentage, that is 50% of this plane length I want the plane to be created. And I select, when I enter here 50 and hit the enter button, it will come exactly to the middle of this particular plane. Now I don't want it with the percentage, I want it to be at the arc length. You can specify the arc length, say 100 mm. So from here 100 mm the plane get created. So that's the use of on curve. And view plane is, say for example I select this, it creates a plane with respect to this workbench view. Say for example I rotate the screen, so according to the screen the plane would change its orientation. As you can see here, now I change perpendicular, almost perpendicular to it, it's changing its orientation. So with respect to the screen, it will create the plane. So that's the use of the view screen, view plane. So next we'll move on to the synchronous modeling. This synchronous modeling is actually used to create or make changes to the models that does not have a parameters. Usually when you try to create a model in UGNX, there will be parameters created over here that is corresponding to the part's history. That is, say for example, I create a cylinder like this. It would record all the operations whatever you're doing in the part navigator. First I created a plane. So in that plane I'm going to create a circle. I came out of the circle, so the sketcher is being captured here. Now I'm going to extrude this. So as you see here, it keeps on building up the history of this part. So this is what called as parameter, and they called it as parametric modeling. So if you export this as a, say I'll export it as a parasolid desktop, I export it here, and now I delete all these things. So now the part has been deleted. Now I import the same parasolid. If you see, it does not have any parameters. It is just a body, but it looks like the original one, but it does not have any parameters here. Now for this body, if you want to make any changes or any changes to it without the help of the parameters, that is when you'll go to this synchronized modeling. So under the synchronized modeling, you have several options like move face. This is actually used to move, say you can directly select that particular face and then pull, so that you can change the dimensions of the original body. So this way you can make changes. Correspondingly, you have offset regions, replace face, delete face, and there are much more. You can explore these tools. So you will get an overview of what exactly each and every tool does here. So replace face, I want to replace this face with another face like this. Then I will select replace face, select the first face, and I will select the second face. As you can see, it has been replaced with the sheets face. Next, delete face. If you have a surface like this and there is an object here, you want this face to be replaced with this particular surface face, then you select delete face. You select the delete face and then the cap option. This is the cap face. You select it, so this face has been replaced with the cap's surface face. So this is how the end result is. So that's the use of delete face. So if you like this video, hit that like button and share max. Until then, bye. Santosh Kumar signing off.